Hey, welcome. Today we're going to dive into the simplest, the lightest, and believe it or not, the most common element in the entire universe. It's the fuel that powers the stars, it's the H in your H2O, and it's the invisible foundation of, well, just about everything. This is the story of hydrogen.
Everything about hydrogen starts right here with the number one. We're talking one proton, one electron. That's it. That's the whole recipe. And this beautiful simplicity is the key to everything else it does. It's not just element number one on the periodic table, it is the undisputed number one element in the cosmos. And don't let that simplicity fool you for a second. That massive, blazing energy coming from our sun, yeah, that's just hydrogen atoms smashing together. The huge oceans covering our planet, well, hydrogen is the essential H in H2O. From the very building blocks of life to the massive clouds of gas between galaxies, hydrogen is the element that gets it all started.
But why? Why is this one super simple element so incredibly powerful? What are its properties, its personality, that lets it play such a massive role in the universe? Well, that's exactly what we're here to find out. So let's start at the beginning. What exactly is hydrogen? And how do we even figure out this elemental superstar existed in the first place?
So here it is in all its minimalist glory. You've got a single proton sitting in the nucleus and just one little electron zipping around it. That is it. This incredibly simple structure makes it the lightest of all the elements. And it's not like it's rare. Get this, it makes up an incredible 90% of all the atoms in the known universe. Just think about that. But we didn't always know about it, of course. Our understanding was built piece by piece, kind of like a detective story. Way back in 1672, Robert Boyle first realized, hey, this is its own unique thing. Then a century later, in 1776, Henry Cavendish made a huge discovery. When you burn hydrogen, you get water. That was the final clue that led the great chemist Antoine Lavoisier to give it the perfect name, hydrogen, which literally comes from the Greek for water producer.
Okay, so we know what it is, but what is it like? If hydrogen walked into a room, what would we even notice? Let's dig into its really unique properties.
Well, physically, hydrogen is basically a ghost. You can't see it, you can't smell it, you can't taste it, and it's completely non-toxic. But the one thing you would notice is its incredible lack of weight. It's the lightest substance we know of, a mind-boggling 14.4 times lighter than the air you're breathing right now.
And this shows that property perfectly. On the left, you fill soap bubbles with hydrogen, and they don't fall, no, they shoot straight up. Then on the right, you can literally see hydrogen gas in one test tube flowing up into the tube above it, pushing all that heavier air right out of the way. It's almost like an anti-gravity gas.
Now, hydrogen's relationship with fire is, well, it's a fascinating paradox. If you take a lit candle and stick it inside a jar of pure hydrogen, the flame actually goes out. See, hydrogen itself won't keep other flames going. But right at the mouth of that same jar, where the hydrogen meets the oxygen in the air, the hydrogen itself bursts into flame. So it burns, but it won't help other things burn. Kind of weird, right?
And when it does burn in the air, oh, it does it with a signature sound. Anybody who's ever taken a chemistry class knows this one. That sharp, distinctive pop, the classic telltale sign that, yep, you've made some hydrogen gas.
Okay, so we know what it's like. But how do we actually get pure hydrogen? Where does it come from? Let's look at how it's made, from a simple little lab experiment all the way up to a massive industrial factory. The key to making it in the lab is this chart, the activity series of metals. The easiest way to think of it is as a reactivity ladder. Any metal that's higher up on the ladder than hydrogen can basically walk up to an acid, kick hydrogen out, and take its place. But the metals below hydrogen, they're just not reactive enough to pull it off.
And here is that exact principle in action. You drop some zinc, which remember is above hydrogen on the ladder, into acid, and boom, you get a fizzing reaction, releasing all those bubbles of hydrogen gas. Now try the same thing with copper, which is way below hydrogen. Nothing, it just sits there. This one simple rule is the secret to making hydrogen in the lab.
Another way to get it is to just rip it straight out of water using electricity. This process is called electrolysis, and it basically uses an electric current to split water molecules into their two parts. As you can see in this diagram, the hydrogen gas bubbles up and collects on one side, while the oxygen collects on the other.
Now, for making huge amounts, industry uses something called the Bosch process. Think of it like a three-step recipe.
Step 1, you blast super hot steam over white-hot coal to create this mixture called water gas. Step 2, you react that gas with even more steam to squeeze out as much hydrogen as possible. And finally, step 3, you scrub away all the leftover carbon gunk, leaving you with pure hydrogen.
So, we've made all this incredible gas. Now for the fun part. What do we do with it? Let's take a look at some of hydrogen's most important real-world uses. Remember how hydrogen burns? Well, when you mix it with pure oxygen, you get an oxyhydrogen flame that can reach a scorching 2,800 degrees Celsius. I mean, that is just insanely hot. And that intense, clean heat is absolutely perfect for welding and slicing right through thick metal.
Hydrogen also plays a huge role in the food we eat, which might sound weird. Through a process called hydrogenation, manufacturers bubble hydrogen gas through liquid vegetable oils. And that simple chemical trick transforms the liquid oil into a semi-solid fat. It's the magic behind things like margarine and all sorts of other spreads you find at the grocery store.
But maybe hydrogen's most critical job is in making ammonia. By reacting hydrogen with nitrogen that's pulled right out of the air, we create the key ingredient for modern fertilizers. Now, this isn't just some small industrial process. This single reaction is responsible for feeding an estimated half of the entire human population. Without it, our world would be a very, very different place.
Okay, for our last stop, let's touch on a really fundamental concept where hydrogen is an absolute star player, the chemical dance known as oxidation and reduction. It really is all about giving and taking.
Now, the name oxidation is a little misleading because it's not always about oxygen. From hydrogen's point of view, it's really simple. If a substance loses a hydrogen atom during a reaction, we say it's been oxidized. It's one half of a fundamental chemical trade.
And of course, every chemical action has an equal and opposite reaction. So, if a substance gains a hydrogen atom, we say it's been reduced. Oxidation and reduction are just two sides of the same coin. It's a transfer of hydrogen from one thing to another. You can't have one without the other.
Let's actually watch this dance happen. Look at the hydrogen sulfide. It comes into the reaction with hydrogen, but it leaves as just plain sulfur. It lost its hydrogen, so we say it was oxidized. Meanwhile, chlorine comes in all by itself, but it leaves attached to hydrogen. It gained hydrogen, so it was reduced. This simple give and take is what we call a redox reaction.
So, from the engine of a star to the basic give and take of chemistry, hydrogen proves that sometimes the simplest things are the most powerful. It really makes you wonder what other incredibly complex systems in our world are actually built on the simplest possible rules.